The second necessary life function would be metabolism. All chemical reactions going on in the body all the time together, that is our body's metabolism. It can be divided into two parts. Catabolism or breaking. For example, we are digesting food and breaking food particles into small molecules. And anabolism, that is building. When you exercise on the regular basis, your muscles are growing, so muscle cells are building structures. Next one, necessary life function would be responsiveness. That is ability of our body to sense and to respond to stimuli. What is a stimulus? Anything. If you hear a loud sound, you will turn your head, that would be your response. If you see a bright light, you immediately will close your eyes, at least you will blink for a moment. Withdrawal reflex is when we touch something that is very hot or maybe painful, and we immediately take away our arm or our foot when we step on a sharp object, for example. That is withdrawal reflex, and it's also an example of responsiveness. Our body keeps responding to internal and external changes even when we are asleep. If we are asleep and it becomes really hot in the room, we start breathing faster. That's a control mechanism of our breathing rate. Next one, movement. We can move our body parts by our skeletal muscles. We can take objects, we can walk, we can run, and we also can produce movement inside of our body, and we cannot even control that. It just happens. Our heart is pumping blood using cardiac muscle, and smooth muscles inside of our stomach and small and large intestines and blood vessels, they can move substances through the body. Number 5 necessary life function is development, growth, and reproduction. We'll start from differentiation of cells. When our blood cells are produced, for example, they all are coming from stem cells. There are identical stem cells in our bone marrow, and depending on what type of blood cells our body needs right now, those stem cells can turn into white blood cells, red blood cells, platelets. That is called differentiation of cells. Increase in size of a body part or an organism. Increase inside of a body part can happen, for example, when we use a lot that body part. A muscle will increase if you exercise that muscle. Bones can be increased also, but only when bones are growing in a child. The whole organism is increasing in size when a baby and infant and child is growing. Cellular division for growth or repair. When we are growing, we need more cells. When some tissues are damaged, the damage should be repaired. For that, we need new cells. Where from we get those cells? Our old cells divide and produce new cells. If you remember, the process of cell division usually is called mitosis, but we have a very specific meiosis only for sperm cells and egg cells production. And finally, reproduction or production of offspring, simply meaning having kids. So those 5 are necessary life functions. Next one, requirements for human life or survival needs. What do we need to stay alive? First of all, we need oxygen. How long do you think you can survive without oxygen? Think about it. Can you survive for an hour? No, absolutely not. Just a few minutes, up to 7 minutes. Oxygen is essential for energy release, and energy for our cells is ATP molecules. Those ATP molecules are produced in our cells only when cells have oxygen. Without oxygen, cells start dying because they do not receive energy. Number 2, nutrients. Nutrients are all the chemicals we mostly receive with food for energy and cell building. To produce ATP we need oxygen, but not only, we also need glucose molecules, and we receive those molecules with food. To build our cells we need fats, we need proteins, we also need different types of minerals and vitamins, and we always need a lot of water. Water is the most abundant chemical in the body, and it's site of chemical reactions. Survival needs. Number 3. Narrow range of temperature. Human body can survive, stay alive, and feel good only in a very narrow range of temperature. Will you feel good if it's 120 outside? It can happen somewhere in the desert. No, you will not, and you will not survive outside for long at temperature like that. At the same time, if the temperature is very low, like minus 40, you also cannot survive long outside without special protection. And finally, number 4, narrow range of atmospheric pressure. We usually don't even think about that pressure, we take it for granted. It's a pressure of air, and approximately it's 760 millimeters of mercury. We need it for adequate breathing and gas exchange in the lungs. If atmospheric pressure changes, for example, if you've ever been high in the mountains, let's say 9 or 10,000 feet above the sea level, was it easy to breathe there? No, it wasn't easy to breathe because it was a different atmospheric pressure there. Homeostasis and negative feedback. Guys, homeostasis and negative feedback are processes going on in the body, so for this portion of the lecture it's a must to read your book. Pay attention. Just a reminder. So what is homeostasis? It is a maintenance of a relatively stable internal environment despite continuous outside changes. We keep our heart rate, we keep our body temperature, our breathing rate, level of the hormones in our body pretty much the same. Doesn't matter what's going on, if it's raining outside or if it's sun shining or if we are sitting or standing, we still maintain that stable internal environment. At the same time, it's not a static, it's dynamic state of equilibrium. For example, your heart rate is not always, let's say, 75. Sometimes when you are asleep it can be 60. Sometimes when you are walking it can be 95, and both would be normal. So, a normal range is a restricted set of values that is optimally healthful and stable, like a heart rate is normal between 60 and 75. Approximately in the middle of that normal range will be a set point. For the heart rate it would be about 75 beats per minute. Another example. What is the level of glucose, or usually we say sugar level, in our blood? The normal level of glucose is from about 70 to 100. And about 75 again would be a set point. Negative feedback is a control mechanism of homeostasis that reverses a deviation from the set point. What does that mean? Sometimes our normal range is broken. Our temperature can go too high, our heart rate can go too high, our blood sugar level can go too high or too low, but our body usually is capable to return all those parameters back to the normal range. So negative feedback is a mechanism that maintains body parameters within their normal range. So again, what is a homeostasis? Relatively stable internal environment. It keeps a lot of things within, we call them values, inside of the normal range. In the middle of the normal range, there is a set point. And the mechanism that maintains homeostasis is called negative feedback. So that control mechanism, negative feedback, it has several components that you're supposed to know about. First of all, to return something to normal, we need to know that it's out of normal. If your body temperature goes too high, your brain needs to know about it. That's why all over the body we have receptors or sensors. They monitor the environment inside of the body and they respond to stimuli. If something changes, those controlled variables change, receptors respond to it by sending information into the control center. So if your body temperature goes too high, your brain knows about it soon. Or if your heart rate or your blood pressure is too high, your brain also will know about it. Or for example, level of certain hormones is too low in the body, and again, receptors send information about it to the brain, to the control center. Brain determines the set point at which the variable is maintained. It receives input from the receptor and it determines appropriate response. What does that mean? Let's say receptor checks your heart rate and it is 90. It sends information to the brain. Is any response necessary? No, because it's a normal heart rate. So there will be no response in this case. In another case, our normal body temperature is 36-37 in Celsius. So if body temperature goes above 37, like it becomes 39, receptors send information to the control center, brain, about it. Then brain has to do something to change and to return that body temperature back to normal. Our brain will do it through effectors. Effectors are organs or structures that receive output from control center from the brain, and they do something. They provide the means to respond, and response acts to reduce or enhance the stimulus, feedback. In case with the body temperature, brain received information from the receptors that body temperature is 39. It's too high. Brain immediately sends a signal to effectors, which would be sweat glands. Sweat glands starts producing sweat all over the body, and when we are sweating, evaporation of that sweat cools down the body and temperature returns back to the normal range. That's how negative feedback is working. Again, guys, please read your book and be able to give your own examples of negative feedback. In very rare cases, when something changes in the body doesn't try to return it back to normal, it supports the change. That is called positive feedback. The best example of the positive feedback probably would be pregnancy and childbirth. When a baby is growing inside of the mom's uterus, it causes a lot of changes in the woman's body. Its size changes, its shape changes, position of the organs in the abdominal cavity of the woman changes, and her level of hormones changes. Will body resist that change? No, the body will support the growing fetus and then the childbirth. So the response enhances or exaggerates the original stimulus, and that is called positive feedback. What is homeostatic imbalance? When our body cannot keep things, different variables within the normal range, it causes disturbance of homeostasis, and that increases risk of disease, and it can cause disease if it's not corrected. So, disturbance of homeostasis increases with aging. That's why older people more often get sick comparing with young people, on average, of course. And it also may allow destructive positive feedback mechanisms to take over. So sometimes we cannot recover from the disease. Our homeostasis will not return back to normal, and it can cause very serious complications like heart failure and even death.